Okay, so to pick this up here, each of these little structures is a thylakoid. Thylakoids are structures that absorb light energy. A stack of thylakoids is called a granum. Grana is plural, granum is singular. Now, let's take a look at the different kinds of electromagnetic energy. Invisible light is a type of electromagnetic energy. So electromagnetic energy is energy that travels in waves. So let me just draw a wave here. Okay, so when we look at a wave, it's going to have what are called crests, so these are upper parts, and then troughs, which are the lower part. Now, wavelength is the distance between one of these crests to another crest here. So that's one wavelength. You could also measure it from trough to trough, so that would be another wavelength as well. Okay, so that's one of the ways in which we characterize this electromagnetic energy is by its wavelength, and another is by its frequency. So frequency is how many waves occur per second. Okay, so how many wavelengths occur per second. All right. So we looked at the electromagnetic spectrum. This is a spectrum of naturally occurring radiation. So just to let you know, radiation and light are the same thing. All right. So when you look at this, you see visible light is in the middle, and then infrared or heat here, microwaves, radio waves. Here's UV light, X-rays, gamma rays. Okay. So we look at the numbers at the top. N means nano, M means meter. So a meter is about this long. And a nanometer is a billionth of a meter. So if we take this and we chop it up a billion times, that's 1 nanometer. All right. So you can see here, these wavelengths are pretty large. So that's a 1 kilometer there. These are very, very, very small. All right. So we look at the amount of energy these waves have. Is that if they have a shorter wavelength, that means they're going to have a higher frequency. So they're going to have a higher amount of energy. So these are high energy waves. So much energy on there that they can break chemical bonds. Over here are these wavelengths they have long wavelengths, they have low frequency, and so they're lower energy. So radio waves are the lowest energy of these waves. Okay, so right here in the middle is visible light. And visible light has enough energy to energize molecules. These guys do not. These guys have enough energy, they can knock electrons off of atoms, and in doing so, break chemical bonds. Now, a photon is a fixed quantity of light energy. And a photon of visible light can energize these electrons enough to move them to a next energy level. These guys, a photon of those can knock that electron off. So let's take a look at types of sunlight. All right, so if we go to the next picture here, just showing this here. So types of sunlight, light that we get from the sun. One is ultraviolet radiation. Ultraviolet radiation is high energy light that can remove electrons from atoms and break chemical bonds. It's about 4% of the sunlight. Ozone blocks it, but it can pass through glass. So ultraviolet radiation is what can give you a sunburn, right? All right, so just know that if you have your arm on the window of a car and the window's up, you can still get a sunburn then. Next is infrared light. Infrared is low energy light. It's about 52% of the sunlight. This is commonly known as heat, and this cannot pass through glass. I'm going to come back to that in a second. Next is visible light, so we'll just go back to this picture. This is just enough energy to energize molecules. It's about 44% of the sunlight. So pigments are going to absorb the photons, and this is going to energize their electrons. So red and blue light is absorbed best by the photosynthetic pigments. Visible light is the smallest portion of the electromagnetic spectrum, and it's the only part that we can see. Black is the absence of light, where white light contains all the colors of the visible spectrum. So white light coming from the sun or these lights contains all these colors in it. All right? So when we pass this through a prism, the prism is going to bend that light into its different wavelengths, and that's why we start seeing those different colors. Visible light can also pass through glass as well. So this is the reason why your cars are warmer on a sunny day. So visible light and ultraviolet radiation can pass through the glass. that gets absorbed by the interior of your car and is converted to into infrared radiation or heat. And the heat cannot move through the glass, so it gets trapped there. And so that's why the inside of your car is warmer than the outside of your car on a sunny day. And this is sort of analogous to what occurs here with global warming. So greenhouse gases, like the glass of your car, trap infrared radiation on the planet. This can be a good thing. In a lot of ways it is a good thing, but we'll talk about runaway, the greenhouse effect, later on in this chapter.